Good morning, grade 9. Today we're going to discuss the most important skills that you have to master in chapter 7, which is chemical formulas and chemical compounds. So what do I mean by a chemical formula? And we're going to start discussing page 207 in your book. So basically a chemical formula is like the one that you're seeing in front of you. This is called also a hydrocarbon. Now, it's called a hydrocarbon because it's made of hydrogen and carbon. And this is a chemical formula. So, and it indicates the relative number of atoms of each kind in a chemical compound. So, for instance, and it's also used to show you the number and kind of atoms in a compound. So, as you can see here, this chemical compound shows you that you have 8 atoms of carbon and 18 atoms of hydrogen. This also shows you that the first part also is always called cation, which is the positive ion. Okay, we always call that, and the anion is the negative ion. Okay, so and these two together form what we call a chemical formula. And this is what is used in chemical equations, and that is going to be discussed in chapter 8. So, but the question right now is that how do we combine? How do we combine monatomic ions? Now, what do we mean by monatomic ions? These, and they're telling you that they're made of only one type of atom. As you can see, I've underlined some of the important lines that you should be paying attention to in your book. So basically, the main group elements, which are made of group 1, 2, 3, and 1 and 2, 13, 14, 15, 16, and 17. These are the main group, the S and P block elements. Now, if you remember before, we've discussed this, and I'm sure that you have this as a note in your notebook about these groups. We said that group 1, okay, so if I want to very, very quickly open on the periodic table that you have, as you can see, group 1 is always +1, group 2 +2, and then we go to group 13, which is +3, group 14, plus -4, -3, -2, and -1. Okay. So the main group elements, one of the most important characteristics about them is that they only have one oxidation state. Okay, they have one oxidation state, and that is actually something that makes combining other anions or cations together easy. Okay, and they're just giving you some examples here, but that is all summarized in this table over here, as you can see. And I wrote a note, memorize this for SAT. Okay, so you have to know this. So what do I need to know? The main group elements, as you can see, they have a +1, +2, +3, and then -1, -2, and -4. And they tell you these elements. They give you the ions. And then for the D block elements, the transitional elements. Now, one of the main characteristics is that these transitional elements, most of them have multiple oxidation states. Okay, they have different ones. So, for example, as you can, I've drawn some arrows between the most common elements or ions. So, for instance, you have copper 1. Now, see this Roman numeral over here? Yeah, these Roman numerals, as you can see over here, are given only to those ions that have multiple ions. Okay, so copper, there's copper 1 and there's copper 2, as you can see. There's iron 2, and the see 2, the Roman number over here, and then in the parentheses, and then you have iron 3. You have chromium 2, and you have chromium 3. You have vanadium 2, vanadium 3. Also, you have tin 2 and tin 4. Okay, and lead, you have lead 4, you have lead 2. Okay, just keep to concentration when you're combining together. Now, how do we combine? So there are basically two methods to do this. There's the crisscross method, okay, and there's the other method that we've discussed in class before, which is making the sum equals as a linear equation, if you remember that. So basically over here, you can see Mg is combining with Br. And when Mg combines with Br, we have to assign the oxidations. So we have +2 and -1 over here. Now, as looking at both oxidation numbers and being different, we have to make them alike. So what we do is the crisscross method. The Br is multiplied by this 2, and the Mg is multiplied by the 1, so you get MgBr2. And this is called magnesium bromide. Magnesium bromide. Another thing is how we name our ionic compounds. Ionic compounds are named now as follows. First thing you have to notice is that the metal is always named by its name. Metals are always named by their names. So we say magnesium. So for all, let's go back to our periodic table. So for all metals in group 1 and group 2, they are called by their names. So we say calcium, for instance, we say calcium, potassium, rubidium, strontium, sodium, lithium, beryllium. Okay, so we say, and then for the anions or the negative ions, which are mainly group 15, 16, and 17, these are given the suffix "ide", IDE. Okay, so we're gonna say, for instance, magnesium chloride, or fluoride, or amide, okay, or oxide, or sulfide. Okay, let's go back. Let's go back over here. So this is the first method, okay? The second method that you can apply actually to find out the combination between these two is that you simply say, so what you're going to do is just say that, okay, so Mg is +2, Br is -1. These, they have to add up to 0. So for that to happen, the -1 has to be -2. And that only applies if I multiply it by 2. And then the number that you multiply by, you add it over here and you put 2. So that's how you get MgBr2. These are just other examples on how you do it. +1, I is -1. They combine easily. Mg is +2, Cl is -1. Do the crisscross method, multiplied by 2. Na is +1. This is -2. So you do the crisscross method. The Na is by 2. Same thing over here. Aluminum +3 and sulfur -2. So what you're going to do is that these are totally different, as you can see. So you do the crisscross method. Okay, this is multiplied by 2. This is multiplied by 3. And just as we said here in this page, it just shows you that we have iron. We have iron 2 and we have iron 3. Also over here, we have lead 4 and we have lead 2. And this is why we have PbO2 and we have PbO. So these are both lead oxide, but this is lead 4 oxide and this is lead 2 oxide. Same thing applies here for some practices. Just how to combine here. They give you the charges, but you have to know that you have to memorize these charges, because in your SE test, these won't be given. You have to know the charges, and or actually in the next section you're going to be asked to find out. Okay, here we show some polyatomic atomic groups like nitrite and nitrate. Just notice that the one that has more oxygen atoms is always given the suffix ate.